The topics that we'll cover would be like this. We may change some slightly, but generally they'll be like this. So we start with an overview, which will do this lecture, and we'll study the OSI Open System Interconnect Reference Model, which is the mostly wide used networking model, and we'll see the network models. Then we'll go to physical layer. So we'll study the network as a layered structure. So we start from the lowest layer, which is the physical layer. We'll study transmission media, and we know different transmission media used nowadays in computer networks. Then we'll move to the next layer, which is the data link layer. We study the data link control sublayer, and then the media access control sublayer of the data link layer. We'll study wired LANs and wireless LANs, and we'll study connecting devices and VLANs. So this is a general overview of the course, actually, not the lecture, this lecture. Then we'll move to the network layer. So we started physical, then we move to data link layer, then we go up one more layer, which is the third layer, or the network layer. We'll study logical addressing. We'll understand what is logical addressing. We study internet protocol, IP. We study the network layer protocols like IP and ICMP, and maybe some other protocols. We'll study some debugging tools used in networking to check if you have some problem with your connection, like ping, traceroute, and we'll study unicast routing protocols like distance vector routing, link state routing, and some other protocols. Then we'll go up to the transport layer, and we'll study the transport layer services and the transport layer protocols, UDP, TCP, and SCTP. Actually, we'll study also application layer, and we'll study some protocols in application layer like DNS, like DSCP, and some other protocols. They are very important, and we will cover actually in this course. So these are the main topics that we'll cover in this course. So how you'll be assessed? Actually, this is we'll follow nearly this assessment scheme. So 10% of overall grade is on homework, and 10% on quizzes. Then we'll do a midterm exam. This will be in Compass. You'll not do it online, actually. Okay, and this one, the final examination, both will do at university. Then we have 10 on lab, which includes reports, quizzes, and exams. And then you have 10% lab final exam. Okay, we have the Cisco course, so that will also have some credits. So maybe I'll slightly change this and then let you know the final grading scheme. Okay, but generally it will be like this. The Cisco course this year, we need you to do the chapter tests, to do some quizzes, and to read. I'll show you later how an overview of the course, but I'll ask you to do some labs and some chapter chapter end of chapter quizzes, like there are quizzes and tests that you need to do. Some of them you'll do at your own time at home, for example, but we may ask to do some of them at university when we go back to lab. Okay, so some quizzes you may do on your own, and some of them you'll do, but generally I may give 10% on the Cisco course. Okay, so the lab grade, instead of 20, will go up to 30 if we say that Cisco is also included in the lab, but it's generally the same topics that we study in the theory, but there are some labs and some what we mean by data communications. So generally, data communication is meant to share information. So if you have something that you want to share with someone else, you need to communicate. So that's what we mean by communication. Telecommunication, from the name, you see that tele means what? Telephony, the name came from, which includes telephony, telegraphy, television, means communication at a distance. Tele is a Greek word for far. So telecommunication means what? Far communication. You communicate with someone that's not next to you, because if it's next to you, then you can communicate by voice. Now I'm communicating by voice, but I'm using telecommunication because you are not close to me. Okay, when we are in a class, we use voice and visual, which is not tele actually, but now we are using telecommunication. So telecommunication means when you want to communicate with someone or something far, not close to you. So you need to use some media, some sort of technology to do that. Data refers to information. So if you want to, when we say you need to communicate, you have something to communicate. That thing is data. So data refers to information presented in whatever form is agreed upon by the parties creating and using the data. So these data should be recognizable to both sides. So if I'm talking now, I'm talking in English. If you don't understand English, then there is no point of this communication, because it's useless. Okay, so data should be known to both sides. What format, what we'll study these ideas later. Data communications are the exchange of data between two devices via some form of transmission medium. So we have a sender, we have a receiver, and we have data, and we have what? Transmission medium. For data communication to occur, the communicating devices must be part of a communication system made up of a combination of hardware, physical equipment, and software, like programs. So I'll ask you a question now. Who can answer? What are the components of a data communication system? Who can answer? We already said them. What are the components of a data communication system?
سيدا
بالي كلامك.
transmission medium, receiver, and transmitter.
Very good. There is some other component. What is the other component missing? Who can tell me? Now. Okay, I'll explain to you. If I'm communicating now with you, okay, let's say I sent you this data. Okay, this data, let's say this text. Okay, I sent it to you in a text file. Okay, you open the text file and you can read this text. Is that clear? But now I'll, for example, compress this file, okay, or encrypt it. When you open the text file, for example, instead of T I used O, change the positions of letters to encrypt it. Then when you open the file, you cannot read the data because it's just random. Maybe you'll see it, it's not in the recognizable form. So what you need in this case to read the data,
سيدة
Mali,
protocol.
Afia, well done. So we need a protocol. So protocol, when you send data, the receiver should know which protocol you are using. Okay, so these are the main components of a communication system. We have the sender, the receiver, the data, the transmission media, and the protocol. Okay, so data communication devices must be part of a communication system made up of a combination of hardware and software. Now, for example, I'm talking to you. I have a computer here in front of me that takes my voice, encodes this voice, then I have software installed, Windows and for example Zoom now. These are all software that's needed to for the communication system to be complete. So generally we have hardware and software. The effectiveness of data communication system depends on four fundamental characteristics. So we'll have a break, okay, in 10 minutes we'll have a break, then we'll start at at 10 o'clock, the next session. Okay, we'll continue until we get to the break point. So the components or the fundamental characteristics are delivery. So what do you mean by delivery? When I communicate to you, you should be the correct recipient. So if there is a student from grade 1 now in this class, he may not understand what we are talking about, okay? So it should be the correct destination. When I communicate, I must deliver the data to the correct destination, not randomly. So this is an important characteristic. Then you have accuracy. The system must deliver the data accurately. So if I talk to you, and if the channel is bad, for example, and you can't hear anything, or you can just hear some words, but most of the speak is not recognizable because of noise or whatever, then in this case the communication is useless. So we need to accurately deliver the data without errors, or with some errors that are not significant or that are correctable. We study these all also. So timelessness. What is meant by timeliness? Timeliness means the system must deliver the data in a timely manner. Okay, so if I'm talking to you and the time for my words to reach to you is very long, then you may notice there will be some we call it jitter. So the word that I'm talking now may get after the another word, so there'll be some jitter noise, and that will affect the quality of the communication. And sometimes, for example, you in real time communication, when you have video, for example, if you have real-time video, for example, you are watching a football game match, okay, and something happened to the communication channel, okay, the signal, the data were there was a delay in the data. So at the point that there was a goal, the wrong thing, something went wrong. So that moment has been shifted. So for example, you will see that moment after 2 seconds or 3 seconds, which means it's not in the real time. You've noticed, for example, in this is actually very important in real-time communication. So delay is very important. Sometimes when the for example, I'll give you another example. When you talk in telephone, sometimes there is jitter, so some words will get delayed, so they will go somewhere that's not appropriate. You are talking now, and some of your talk been delayed, for example. This is timely data. So if it's not coming in its exact time, or it's in a right sequence, it will be useless. This is a very important issue, as we said, with real-time communication. We may see some examples of this also, but we'll not actually put much emphasis on real-time communication, because we'll study mostly IP, which is it's okay with delay. The other aspect is jitter. Jitter refers to a variation in the packet arrival time. So some packets may arrive in time, some packets may arrive later, some packets may arrive faster. This is called jitter. This is this uneven delay in the delivery of audio or video packets. For example, let us assume that the video packets are sent every 30 milliseconds, which is depending on the frame rate. If some of the packets arrive with 30 millisecond delay and other with 40, an uneven quality in video is a result. What we do, you are watching YouTube video. This happens actually. But how YouTube overcomes this? Who can answer this question? It's very simple. You see, there are packets arriving early and then some later, and the delay is variable. How you can overcome this problem? If it's not real-time communication, because when on YouTube you are not watching real-time video, that's very easy to solve. But in real-time communication, this is a hard problem, like voice or video communication, real-time video communication. This is a very hard issue. So if some packets are getting delayed more than a window, a allowed window, then they will be discarded actually. So how we can solve this? Some packets are arriving in 30 milliseconds, but some of them are arriving with 40 millisecond delay. We can easily, if we just collect the packets, you see when you watch videos on YouTube, there is the loading and then there is it's called the queuing. So we queue the packets, we collect them in a queue. You know what's a queue. Then we sort them, the ones that we arrive first and then the ones that arrived later. Of course we have packet IDs, so we can sort them, which one is before which one. So in this case the delay, even if it's uneven, is not an issue, because we have a buffer that will put all these packets and then we'll watch later. We'll not watch them instantly, because if you watch instantly then there'll be this problem and you cannot see the video properly. So you'll buffer, for example, 1 second, 2 seconds, then after that you start watching the video. So the jitter is not an issue, a big issue with if the communication is not real time. It's mainly a real time communication issue. So here are the components of a data communication system. So as we said, we have to have something to send, first thing, okay? Then you send the message and there is someone who receives the message, and you need some medium to send this message through. For example, now I am using different mediums actually. At home I am communicating wirelessly to the router. The router may be communicating to the internet via a LAN cable. The internet, at university, for example, may be communicating via fiber. So there are different mediums from here when I talk to you when you hear me. Okay, so we have to have a communication medium.